Today, we're going to talk about vectors, and I'm also going to talk about how vectors are going to play into polar coordinates, what we talked about yesterday. So, vectors. Vectors have magnitude and direction. Think about them kind of like a ray from geometry, just a ray that has a stationary length. So the magnitude is what we call the length, obviously, and the direction is where you're going. This is the initial point of the vector. It goes for a certain direction at a certain length, and this is what we call the terminal point. Okay, some teachers often call this actually here is going to be the tip, and the part up here is going to be the tail, and that's going to come into play when we talk about adding vectors. And vectors can be put anywhere in our coordinate plane. To make our life easy, most of the time we're going to put the initial point at 0, 0, and then the terminal point any direction. And there's two ways that we can name vectors. We can name them in a regular old XY plane. So they're going to have an X direction over a Y direction up. Or, so we can name them as X and Y. Or we can name them in rectangular coordinates, where we talk about a theta that it rotates up from 0 and the magnitude. And the magnitude is going to essentially be the r that we think of in polar coordinates, and then theta from which you've rotated up from 0. Adding vectors. So say I have two vectors. Okay, this is the initial point of the first one. So you go through some certain length to your terminal point. Then you have the initial point of your second one. So you do what we call tip to tail, where the first one ended, you have the second one and you go a certain direction. And this is going to be, say this was vector v, this was vector w, from the initial point of the first one to the terminal point of the second one, that's v plus w. We're going to get more into that in later sections. Rectangular form. Rectangular, remember, is x and y. And you always go from your initial point to your terminal point. So I go over some x, and then down, and it should be a perpendicular, some certain y length. Okay, so how we would write this vector is x distance, y distance. Now in this case, y would be negative. Sometimes people put vectors to differentiate them from coordinates as x and y in little less than and greater than signs, just a different way of writing it. Now the rectangular form that I've kind of already talked about. Remember, let's always put everything at the origin. So let's look at that as the origin. You're going to have some certain theta that you're going to rotate from, and you're always going to rotate from 0. Always think of 0 as where we're rotating from. You can have a negative degree if you want, but typically we're only going to be dealing with positive degrees. Now the length of that, the fancy way of saying that, is the magnitude. So then we're going to have the magnitude here. And so how we write them in polar forms is the magnitude and theta. The magnitude is always positive. And theta, most of the time, we're going to have it always, most of the time it's always, I would say most of the time, it's going to be positive. Okay, so how does this play in? Give each vector in this coordinate plane in rectangular form. And notice how I have no axes drawn, because they can be anywhere in the plane. So V, we start at the initial point and go in your x direction. You go 1 unit in your x direction, in the positive direction, and then I go 3 negative. For W, start at your initial point. I go 3 positive in the x direction, and I go up 2 in the y direction. So that one's both positive. Give each vector in polar form. Now this takes a little bit more work. Okay, so to get u, its length. Now u is straight up and down. So straight up and down, that's going to be a little bit easier. Okay, from my initial point to my terminal point, its magnitude or its length is 3 units. Now rotating from 0, where that's 0, rotating around, that's 270 degrees. Z. Now Z is a little bit more complicated because it has a direction and a magnitude that's not straight up and down, it goes diagonal. So to figure out the magnitude, think of this as a right triangle. And we're going to be doing that for everything. So one leg is 4, one leg is 1. So the magnitude is the square root of 4 squared plus 1 squared, which is the square root of 17. So our magnitude is 17. Now I need to figure out the theta from 0. From 0, rotating around, I need to figure out that theta. So I need to figure out that small little angle in there. That small little angle, the tangent of that angle, I'm going to call it alpha. Alpha is just another Greek letter that we sometimes use for angles. The tangent of that is opposite over hypotenuse, so 1 over 4. So I do inverse tangent in my calculator to get what alpha is. And that ends up being, so that ends up being 14.04. But that's this angle. We need rotating from 0. So I'm going to subtract that from 180. 180 minus 14.04 to get 165.96. Next example. Here we have converting this vector to polar form. I'm going to draw out a little picture of this so that we know what it looks like. So from 0, 0, our vector goes 3 to the left and up 5. So from 0, 0, I go 3 to the left, up 5. That is our vector, where this is -3, this is 5. So again, to find the magnitude, that's the hypotenuse of that right triangle. That's the square root of 5 squared plus 3 squared. You could use -3, but when you square -3, you get the same thing. That's going to be the square root of 34. Now to get the theta, the tangent of theta is equal to opposite, so theta, I'm calling this theta, even though the angle that we want rotating from 0 is that one. So I'm calling that theta, the tangent of theta is -5 over 3. So again, we do inverse tangent of -5 over 3. So when I do that in my calculator, I get negative 59.04. So that's what this theta is. It says, yes, it's negative, but think about it as the positive version because we're really dealing with reference angles. So what I need to do is I need to do 180 minus that 59.04 to get the actual angle. And we get 120.96. So our vector has a magnitude of 34 and has a direction of 120.96 degrees. Next example, converting this vector now to rectangular form. Let's look at what we have there. From 0, 0, I rotate 156 degrees, and I have a magnitude of 8. So that's actually really easy. This is the same as when we were converting from polar to rectangular and rectangular to polar. X is going to be the magnitude times the cosine of the angle we're given. The y is also magnitude, but y is sine of the angle that we're given. So all it is a matter of plugging in 8 times the cosine of 156, which is negative 7.31. Y is 8 times the sine of 156, which when I type that in my calculator, I get that. So we have negative 7.31 and 3.25. Now that should make sense. Think of this as an X and Y. I go negative and positive. Yes, that makes sense. So there are your 4 lesson questions for the day. For 1 and 2, please refer back to the very first example, the very first 2 examples that I did.